Welcome to Get It Growing. I'm the host, Rob Trawick, the county agent here in Lafayette Parish, and very fortunate to have with us this week Jay Stevens, who is the state soil, I guess the state soil specialist
Yep.
for just about everything from agronomic crops, rice to ornamentals. So you pretty much cover all bases.
Yes, we do, Rob. We have about 94, 95 crops that we call crops because they are. They're a crop to the lawn is to the homeowner, or the tomato plants to the gardener, or the azaleas in the landscape, all the way on through to the row crops and traditional crops here in Louisiana.
Right. Well, the reason fall is one of those big planting seasons, and this is a lot of times people hear the term fall is for planting. And well, we wanted to take a hold of that. We do a lot of soil samples, and a lot of people will call us up and ask for help with their analysis. They're not sure what the numbers mean. They're not sure about certain things as far as what is pH, what effect does it have on plants and soil and so on. And so it's I thought it would be a good idea to get some things taken care of out there, talk about this, and get some of the myths taken out of there, out of the equation, and just bring the facts to the table about soil analysis. But I had a professor when I was in college that always told us that you take care of the roots, the top will take care of itself for the most part. And when you're dealing with roots, you're talking about soil. So you're talking about taking care of the soil.
When you're talking about soils and soil fertility, what you're actually talking about is soil chemistry. And most folks don't like chemistry, so they think it's mystical.
Well, yeah, I ran away from it in college, so I know what you're saying. But as far as the way things come across, a lot of times people will sit there and they'll take a soil sample. And you want to talk a little bit about maybe some of the tools you have here. We'll talk a little bit about gathering a soil sample. And,
Certainly.
And how it's done, how the process is done through the Ag Center.
If we considered this table right here to be our bed, say in a landscape setting, and we wanted to get a sample from here, we'd want to stop in maybe 5 or 6 places here, even in this small bed, so we get a representation of this bed. If we stop and take a sample right here in the middle, then we represent an area maybe as big as a wash pan. Right. But we need to know what's all out here because most beds have been made from various and sundry soils and our organic particles that folks have brought in.
So basically what you'd like to do is get a broader representation so you can determine
what's going on here. Now, usually we would say that you might want to use a soil probe. Well, this one will cost you about $35. That's not necessary. We want to take a soil sample about 6 inches deep from the soil surface down 6 inches. Well, we could do that just as easily with this soil scoop, you see? And, we could also do it with this little Marine Corps shovel. Just push it in the ground, get your sample. Now, you've got samples here. We'll call these subsamples. And then we always want to take them and put them in a clean plastic bucket. We mix them up real well. And from that, we take the sample that we're going to submit to the LSU Soil Test and Plant Analysis Lab, which Rob has a sample box here. It's just a small thing. It's a ½ pint in size. It's just like a little ice cream box. You take your sample after you mix it up, put it in here, fold the lids. You've written your name on it. You've written your address and the crops you want to grow. Now, we could just as easily have put that in a plastic bag and noted where it came from.
And that's what I have a lot of people, because, a lot of people we have these in ample supply at the Ag Center office, but a lot of people will bring their soil samples, which is just fine as long as they sample them or label them correctly, but they'll bring them in a Ziploc bag just like that to the office. which I want to reiterate is just fine.
But one of the main things that they need to consider is taking the sample properly and giving us a good half pint of soil in the box to send to the lab. In addition to that, they have a general public soil test request sheet that has places on there for their name, address, email address, telephone number, because you'll be surprised. Sometimes we have to call people to find out some issues, particularly if a sample gets squished in the mail. The next consideration, and this is not the way I wanted to do it, but here are the list of crops that we have. If we were going for a home vegetable garden, we have a location on there that says home vegetable garden. If it were for a food plot, we don't have that just yet. However, next year we will.
Right.
If they write down tomatoes, bell pepper, squash, they'll get commercial recommendations in pounds per acre instead of recommendations of pounds per 100-foot of row.
Which when they get those, they can easily call the extension office, me in this parish, other agents in other parishes, and we can help them determine, going from pounds per acre to teaspoons per square foot or so.
Absolutely.
But what we'll do, the big reason I wanted to talk to you about, bring you in and help, was to take away some of the myths that are out there, and also the importance of soil sampling and why it's important to have the proper soil analysis done, and so you have a good baseline to start from.
Excellent thought. The most important step that you take in sampling is the sample and how you take it, because that's going to represent those data that are developed from that in the lab is going to dictate what your fertilizer recommendation is going to be, or if you're going to have to adjust the soil pH. The first thing that I know that you and I look at on a results sheet from the lab is the soil pH.
Yeah, to me I tell people it's the most important number that's on that sheet when they get their results back.
I look at the crop and I look at the soil pH, and then begin to develop my thoughts about that crop, and then look at the level of phosphorus and potassium, calcium, magnesium, sodium, copper, zinc, and sulfur as we have them extracted, and then look at the recommendations that are on there, and look for problem areas within that.
Right, and the thing about if we go back to pH for a second, the pH is just for most people out there, so it's a measure of alkalinity or acidity in the soil. And some crops, like say an alkaline soil, like if we talk about our turf grasses, their St. Augustines, centipede, Bermuda grass, they like more of an alkaline pH with a pH somewhere, I guess, about 7.5 to 8, somewhere in that.
They can withstand that.
Whereas if we're talking about more of a lot of times of our ornamental crops, say we're talking about azaleas or gardenias or plants along those, and oftentimes, a lot of times our annual crops, our pansies and snapdragons, they prefer a pH between, say, 5.5 and 6.5. And if the pH is not accurate, then you end up with the plant starts showing nutritional deficiencies.
Yeah, the plant, did you know plants can talk? They're going to give you some indication that there's a different color or a different growth developmental stage here. They're going to give you some indications that something's wrong. What they're doing is they're really screaming at you, Rob. We've got a problem and we need some help. So to a trained eye, you can determine what's going on. Following that up with a soil test will give you a better indication of what you need and in what amounts. And you can help the clientele with any number of sizes of applications, and how to apply it, where you might find some of these fertilizer materials, or liming type materials, or some of the acidifying materials where folks need to adjust the pH on their soil.
Yeah, one thing I'll like to mention on that is, where a lot of times I'll see a plant that, like you're saying, is screaming at you. That I often see gardenias. They're very sensitive to pH.
Sure.
They like an acid soil, and which, like I said, with a pH between say 5.5 and 6.5, and if they're somewhere around 7, what you start noticing on these plants are the newer, younger growth on it starts to turn yellow, and
Exactly.
you start getting green veins, and it's almost like a soil test in itself. It's telling you my pH is not where it needs to be. It needs to be lower. And you were mentioning some materials like lime, for example, is one of the materials that we use to raise the pH, to make it more alkaline. And some of the materials that I'll mention, like sulfur, is one that I'll mention that is often used to make the soil more acidic. Are there any other? Yeah.
There are some other materials, and then there's various types of limes. You can have just agricultural grade calcitic lime. It's a calcium carbonate. Could be a dolomitic lime, agricultural grade, that has calcium and magnesium in it.
Right.
Raises the pH, but also supplies calcium and or magnesium to the soil. You can use the quick limes, which you'll want to use about 3/4 as much of them as you would an ag grade lime, because the quick limes and the other limes like that are finely divided, real fine, like face powder, react very, very fast. They take that pH up to around 10.5 or a pH of 11, very alkaline, in a short period of time, and then that pH begins to drop back. If folks are using those types that are finely ground and applying them and incorporating them into the soil, generally they'll need to do that application another year, year and a half, because all the particles are small, they react quickly, and that pH begins to come back down.
And that's one thing I want to talk to you while we're on the subject of pH is it's kind of a scientific term, I guess, that we use in a sense, but the buffering, buffered. The more we have clay soils, the more we have the more the soils are what we term buffered or highly buffered, which means they don't like to change pH very often. They don't. You can add lime to it this year, and then you take a soil test again the next year, and it may have, the pH may have gone up, but then it's probably kind of creeped back down just a little bit over time. You want to talk a little bit about that?
Yeah, that's a good point. The buffering of soils to changes in pH are primarily concerned with the amount of clay, the percent of clay that's in a soil, and also the percent organic matter that's in there, because both of these two are the biggest determiners on the buffering capacity of a soil. To say that a very fine sandy loam or even a silt loam, like here on the Lafayette Ridge, most of the soils are silt loam textured.
Which is basically almost like a clay, really.
Well, it's one step back up from a clay. And then when you think about a silt loam soil, like we talk about in our Master Gardener classes, a silt loam contains a range of values for sand, silt, and clay. And as you move closer to the end of that silt loam texture, the percentage up to about 27% clay maybe, then you're beginning to get an issue there with soil permeability or more infiltration of the movement of water through that soil.
Okay.
But those two issues make a big difference in how much lime is added. If you've got a sandy soil, silt loam soil, let's say, with a 0.5% organic matter, is only going to require a small amount of lime. If it's a silt loam soil with 3 or 4% organic matter, it's going to require more lime to satisfy what we're doing in the lab and with something like a little handheld pH meter. we're only measuring the active acidity that's in there. We're not measuring the potential acidity. So all in all, we're looking at a very small part in some soils in the state of Louisiana. The potential acidity is very high.
Right.
But all in all, if you want to change the pH of a soil, increase it with lime of some sort, or if you want to decrease it, you can use elemental sulfur, but wait 3 months for the bacteria in the soil to break that elemental sulfur down to a usable sulfate form that the plants can take up, but more particularly in the soil solution, in the soil moisture, to make it into a weak sulfuric acid, which actually brings that pH down.
Right, and that's why I tell you there are limitations to what you can
Certainly.
put out there because, as you said, one of the byproducts of putting sulfur down to lower the pH is sulfuric acid, and so I believe one of the maximums that you can put down is about 5 pounds of pure elemental sulfur per 1,000 square feet or so.
Yeah, and
one number I've heard.
If you're looking at 5 pounds per 1,000 square feet, let's see, that would be, let's look at it another way. Anything at the rate of 45 pounds per 1,000 square feet is equivalent to 1 ton per acre equivalent. So we're 1/9 of that, right?
Yeah.
So, 1/9 of 2,000. I've got my calculator. Let's do it.
Let's break it out.
Let's see here. We got 2,000 pounds.
9.9.
Let's divide that thing by 9. I cannot remember my decimal fractions. Conversion, that's about 222 pounds of elemental sulfur applied. The main thing is that folks don't do their homework. They don't get their samples in sufficient time to go out and prepare the soil and change the chemistry in advance. Now, if you're building a new bed or have a new area and you get a sample, you can, before you establish it in whatever vegetative plants you want, you can adjust it downward with aluminum sulfate or alum. The housewives know about alum because they use it in cooking. But the main thing is you have to use 6 times as much alum, aluminum sulfate, as you do elemental sulfur because alum is only about 16% sulfur. But both sides of that equation there, aluminum is acidic and sulfate is acidic, and you need to treat it as a fertilizer. Apply it, water it in, incorporate it, water it in. The big thing is, we in the Extension Service only recommend using 1/3 of that amount at any given time, and particularly being cautious from the standpoint of applying just that small amount, waiting 2 or 3 months, and then checking that soil pH again, because if you put the whole amount out there, you have enough acidity that's going into the soil to quote unquote burn the tender feeder roots off of the plants.
Right.
And that's not where we want to go. We're trying to improve the situation.
And it'll cause more damage than
Oh, absolutely. And then you'll be going back to the nurseryman again.
Exactly, which they probably wouldn't mind. But well, let's talk a little bit about some of the nutrients. One thing you won't find, a lot of times people find alarming when they get a soil sample run, is you won't find on a soil sample sheet nitrogen, the percentage of nitrogen in the soil. And you want to explain a little bit about the reason for that?
The theory behind that is that here in the Mid-South, and almost particularly, I want to call this the subtropics here, we have warm enough temperatures year-round in the soil so that the nitrogen is never in a steady state. It never reaches an equilibrium, if you will. You have the nitrogen cycle is a very complex cycle.
Right.
Some of it's mineralized, some of it's immobilized, some of it comes and goes. It's like the dog that chases its tail. Okay? So we're not going to say, we're going to take a picture, basically. If we took a soil test and ran nitrogen, that's what it was right then when you took that sample. Now, 5 minutes from now, it's different. 2 days from now, it's different. How many transformations has that particular nitrogen taken? Is it now an ammonium? Is it a nitrate? Is it a nitrite? Or has it escaped into the atmosphere as nitrogen?
Right. A lot of times it's unlike your phosphorus and your potassium. You
Right.
find that it washes out very, very quickly too. Now two elements that the next two elements that you find on the soil test sheet, the phosphorus and the potassium, are two that are the other two macro elements that you find on a bag of fertilizer. When we look at a bag of fertilizer, there are three numbers generally. The first number being the percentage of nitrogen, second number being the percentage of phosphorus, more or less,
Phosphate.
phosphate, and then the third number is the percentage of potassium. And those last two numbers, they sometimes what shows up on the sheet that determines what we want to use in a bag of fertilizer. We don't want to keep using maybe don't, because the level of phosphorus is very high, we may not want to use a 13 or
Exactly.
something with a very high number because of that. And one thing I found is because phosphorus has a tendency to cling on or just grab onto these soil molecules, and it doesn't want to let go. It just wants to stay in there and not get washed away. It stays in there. And I guess that's one of the same reasons phosphorus was used in detergents years and years and years ago, was because it had that ability to grab on the soil molecules that were on, dirty clothes and stuff like that, and then carry that away. But it still held on to that soil molecule as it got washed away. But once it's in the soil, it's there for a while.
It's pretty well there from the standpoint of a soil. Mm-hmm. Now, if it were a horticultural mix, which may be for the most part organic, mm-hmm, of one type or another, then you could get some phosphorus that would be leached out from an organic mix. Mm-hmm. You would absolutely get a bunch of potassium that would be leached out. But phosphorus in a soil pretty much stays where you put it. The availability of phosphorus is controlled by two mechanisms, more or less. You can get deficiencies by having too low and or too high pH, and then you can get deficiencies when the soil is very cold.
Okay, I didn't realize the temperature had
It's a big determiner.
Okay. But one thing a lot of times, someone will have done a soil test. Invariably, this happens many times a year. I'll get a soil test that comes in, and I'm looking at the results, and they have 300-400 parts per million, which is a fairly high number. I've even seen one as high as 1,100 parts per million, and I could tell over the phone. I told them over the phone, I was like, I could tell you've been fertilizing using the same 13 or some type of fertilizer like this for a long period of time.
That's true.
And in this garden, and they're like, oh yeah, we've been gardening in the same place for 25 years. And so it's sometimes these numbers can tell us a lot about that particular.
That's in those cases, and I've looked at some of those very similar to that in some of the commercial vegetables in the state and the fruits and vegetables, where families have been using for 2 to maybe 3 generations the basic same fertilizer rate and same material, and they have the phosphorus exceedingly high, which now causes problems with iron deficiency and zinc deficiency, and they're encouraging them to drop back on the phosphorus or don't apply it at all, particularly if their pH is in that 6 to 6.5, for where most of the phosphorus is going to be available.
I guess in a way, what we're saying here is sometimes too much of something is not always a good thing. It's
you're right,
because you get to the point where if you have such a large amount, you can start causing deficiencies in other elements where it's not able to be taken up.
Nutrient imbalance is an issue that you and I have to look at. And many times the clientele don't consider it.
Yeah.
But it's an actual fact that if you're continual fertilization with the same materials over time, you're going to build up those nutrients. And in doing so, if you're putting out high enough rates of nutrients, all the fertilizer nutrients we have are salts.
Right.
And you can build up a salt accumulation in the soil, particularly if that's a silty clay or a clay.
Okay. Well, do you have any quick final thoughts, I guess? We're just
I would say soil test, don't guess.
That's probably the best thing you can say about it. And Jay, really appreciate you being here and coming and
I
talking.
enjoyed the opportunity to visit with you and the viewing public.